Dear student, welcome back in my channel. Today in my class, I am going to explain oxidation state. The chapter, the D and F block elements. Already you know that metal characters. What is a metal character? The tendency to lose the electron to become the electropositive in nature. I am going to explain S block elements, the X block element, the group 1 element and group 2 element. The group 1 elements called alkali metal, the group 2 elements are called alkaline earth metal. Here I am taken the one example, Na atom, here magnesium atom. The Na atom, atomic number 11, magnesium atom, atomic number 12. So the sodium, the electronic configuration 1s2, 2s2, 2p6, 3s2. Here the magnesium 1s2, 2s2, 2p6, 3s2. Sorry, here 3s1. It will be lost one electron from their valence shell. It became the Na plus. Likewise, magnesium also to attain the noble electronic configuration of neon, to release the 2 electron from 3s2 orbital to become Mg2 plus. Here, group 1 elements, we can say the metal plus valency. The group 2 elements, we can say metal 2 plus valency. This is the single valency. But when you are discussing the D block elements or transition element, we cannot say the oxidation state either +1 or +2 or whatever it may be. It has the variation valency, the different valency. The reason is this is a general electronic configuration of D block elements n-1, D 1 to 10, ns 1 to 2. Now you see this ns is a valence shell. This n-1d is a penultimate cell. Penultimate cell. The valence cell and penultimate cell are almost equal energy. So the D block metals are lost the electron from the s orbital as well as the d orbital, so that D block elements are get variable valency or different valency. I am going to explain the 3D series element one by one. You know that the 3D series element scandium to zinc, the scandium, then titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Copper and zinc. Listen, I am going to write the electronic configuration then. The electronic configuration, scandium, argon, 3d1, 4s, 2. Titanium, just I am going to write only the d orbital and s orbital. So 3d 2, 4s 2. Vanadium 3d3, 4s 2. Chromium 3d5, 4s 1. Manganese 3d5, 4s 2. Iron 3d6 4s2, cobalt 3d7 4s2, nickel 3d8 4s2, copper 3d10 4s2, 4s1, zinc 3d10 4s2. This is the electronic configuration of scandium 2 Z10. Already I told you this electron, it will be lost from the s orbital as well as the d orbital. So you see the scandium, when it is attained the electronic configuration of noble gas argon, it is supposed to lose the d orbital electron as well as the s orbital electron, totally 3 electron. So here come the plus 3 oxidation state is a stable oxidation state. The titanium, it will be lost the 2 electron from the s orbital. That time it attained the plus 2 oxidation state. Then one more electron from the d orbital attain the plus 3 oxidation state. When it is lost the 4 electrons, it will be get the 4 oxidation state. Likewise, vanadium also, it will get the oxidation state 2, 3, 4 and 5. Then the chromium 2, 3, 4, 5 and 6. The manganese 2, 3, 4, 5, 6 and 7. This manganese has the highest oxidation state compared to the 3D series 2 to 7. Then the iron 2, 3, 4. This iron do not exist into the plus 5 oxidation state. It is the, when it is exists the plus 5 oxidation state, it is readily changed to the either plus 4 or plus 6. Then so plus 3, plus 4 and plus 6. Cobalt plus 2, plus 3 and plus 4. Nickel plus 2, plus 3 and plus 4. Copper plus 1 and plus 2. Z10 plus 2. The first element scandium and the last element Z10 has only one valency. The scandium plus 3, zinc plus 2. Then the titanium, you see, the titanium, when it is lost the 4 electron, it will be attain the electronic configuration of noble gas argon. So this is 4 plus 4 is a stable electronic configuration. Likewise, vanadium plus 5 is the stable, not the oxidation state. Plus 4 is the oxidation state. Vanadium plus 5 oxidation state. Chromium plus 3 as well as the plus 6 is the stable stable oxidation state. When you compare the plus 4 and plus 6, plus 3 is the stable oxidation state. It will be attained the crystal feed splitting to G energy level. That I will explain while I am going to teach the coordination compound. Then the manganese plus 2 and plus 7 oxidation state is the high stability. Then the iron plus 2 and plus 3. Cobalt plus 2 and plus 3. Nickel plus 2. Copper plus 2. Zinc plus 2. Listen here one thing. This when the scandium to manganese, highest oxidation state is the high stability plus 3, 4, 5, 6 and 7. Then after the manganese from iron to Z10, the lower oxidation state is a high stability plus 1 plus 2 plus 2 plus 2 plus 2 and plus 2. The lower oxidation state is the high stability. This is the one thing, keep it in your mind. Then the next one thing, this is stable compounds, some stable compound of the oxides. The titanium, the stable compound is the titanium oxide. Now it is attained the plus 4 oxidation state titanium. Then the vanadium VO2 minus. This now exists the +5 oxidation state. Then the chromium CrO4 2 minus. This is the +6 oxidation state. Then manganese MnO4 minus. This is the +7 oxidation state. This is a titanium oxide, vanadium oxide, chromium oxide, and manganese oxide. Then the next one we are going to discuss about the group 6 element. The chromium, this is a 3D series chromium, 3D series chromium, then 4D series molybdenum, then 5D series tungsten. These are 3 elements, the highest oxidation state of the +6, the CrO3, MoO3, WO3. Now you listen carefully. This is a chromium trioxide. Chromium trioxide is act as an oxidizing agent. This act as an oxidizing agent. So this oxidizing agent always tendency to gain the electron. So this is a chromium. Now it is a +6 oxidation state. It is ready to gain 3 electrons. It is ready to gain 3 electrons to become the +3 oxidation state. When you are compared to the chromium, +6 and +3 is the higher stability. +3 is the higher stability. But discussing about the molybdenum and tungsten, they are the +6 oxidation state is the high stability. The next point we want to discuss about the iron and nickel. That means nickel tetracarbonyl, then iron pentacarbonyl. Now this is a nickel and iron oxidation state is the 0. This is the oxidation state is the 0. That is happening. It is the complex compound. The carbonyl, which is the neutral ligands. The neutral ligands, it will be give the one pair of the electron to nickel through the sigma bond. Now, when the nickel gain the 2 electron from the carbon, this a nickel density of the electron will be increases. Once increasing the density of the electron, it will be give back the electron through the empty orbital to make the pi bond. So finally, here is the no charge will be attained. This is the neutral compound. So nickel and iron as a 0 oxidation state. Thank you, students. I hope you can understand.